We're going to start with 2.1 conditional statements. Over this chapter, you're going to be learning what we call is reasoning, okay, logic. And so you're going to have to kind of see this over time so you kind of understand this. So let's start with the very basic thing that we need to understand. The essential understanding is that you can describe some mathematical relationships using a variety of if and then statements. The study of if and then statements and their truth values is a foundation of reasoning. So this chapter is a lot about reasoning and logic. So the first thing that we have to understand is the conditional statement. A conditional statement is an if and then statement. Let's just keep it in our world. Computers talk to each other with software, with language. That's kind of what conditional statements are. It's a language. And in geometry, over 2,000 years ago, this book brought up the first software, the first language. And it's called the if and then statements. It's a way to logically look at things and solve things. But that doesn't matter. For geometry, we want to understand what are they, what do we do with them, how do we solve them, or what is it that we need to do for geometry for us to learn this. So let's look at this example right here under conditional statement. If angle A measures 15 degrees, then angle A is acute. Okay? So this is called a conditional statement. It's got an if, and then it says something here, and then it's followed by a then, and then it says angle A is acute in blue. So in a conditional statement has an if and an then. Okay? Alright, we read this as if P then Q. So the P is going to be what's in red. The Q, the angle A is acute, that's going to be the Q, that's going to be the last part. Now in geometry, we also use symbols. They use P, and then they use this little arrow, and then followed by Q. So this means if P, then Q. So this is another way of using symbols. They use a little arrow to represent the then, okay, or to represent the if-then statement. Okay, now, when you have a statement, what it says here in red, angle A measures 15 degrees, we know that is P. Well, that is known as the hypothesis. So this is known as the hypothesis, and this is what it says here. The hypothesis is the part P following the if statement. So this right here, guys, is known as the hypothesis. Okay? What I just underlined and what's in red. So if they ask us for the hypothesis, that would be angle A measures 15 degrees. Okay, now the one in blue after the then, that's this one right here, angle A is acute. Well, that's called the conclusion. The conclusion is, and that's supposed to say is, the part Q following the then. So this part right here, that's known as our conclusion. Conclusion is at the end, so it's very easy to remember. Conclusion is after the then, it's the last part of the statement. So conclusion would be known as angle A is acute. Okay, so there's our hypothesis. Angle A measures 15 degrees. Conclusion, angle A is acute. Now let's go through some examples. Let's build from this and understand the conditional statement and then go from there. So let's look at our first examples. Okay, so for problem 1, it says identify the hypothesis and the conclusion. What are the hypothesis and the conclusion of the conditional? And when they mean conditional, they're talking about the conditional statement. Okay, so what we're going to do is we're going to look at the statement. The statement says, if an animal is a robin, then the animal is a bird. So we want to break it down. First thing is we want to know what is the hypothesis. Okay, well, the hypothesis is after the if, but before the then statement. So it would be an animal is a robin. Okay, so the hypothesis, which is our P, is an animal is a robin. Okay, the next thing is what is going to be our conclusion. The conclusion follows the then. The animal is a bird. So if we want to determine what's the conclusion, it's after the then. Therefore, the conclusion, which is known as Q, is the animal is a bird. Okay, for problem number 2, we're going to write a conditional statement. How can you write the following statement as a conditional? Vertical angles share a vertex. Alright, for us to do this, we first need to write down hypothesis and conclusion. And we need to identify those two on that statement. Okay, so vertical angles share a vertex. Okay, the way I look at this, and the way you should look at this, is you have two statements. The first statement is the very beginning, vertical angles. The second statement is share a vertex. So that's the way I would look at it. You got to be able to see two things here. So for vertical angles, I am going to write that vertical angles, if you go back to 1.4, vertical angles are a pair of angles that cross each other. So vertical, you're going to say it's a pair of vertical angles. Okay, the conclusion is they share a vertex. Alright, so now what we're going to do is we're going to turn this hypothesis and conclusion into the if and then. So we're going to write the following. If, now substitute the, in this case, the hypothesis. If a pair of angles, if a pair of angles are vertical, and let's call it vertical angles. So if a pair of angles are vertical angles, then we can say they share a vertex. Okay, so there's our conditional statement. So that's an example of how to write a conditional. So break it apart, come up with your hypothesis and conclusion, and then try to make sense of it with if and then as a statement. Okay, for problem 3, we're going to find the truth value of a conditional statement or a conditional. Is the conditional true or false? If it is false, find a counterexample. So let's go back to what was a counterexample. From the previous unit, a counterexample is something that makes the statement false. So we want to find out, is it true or false? If it's false, we need an example to prove that it's false. So let's start with the first one. The first one says, if a woman is Hungarian, then she is European. Okay? Well, Hungary is from Europe. So if she's a woman and she's from Hungary, she is European. Therefore, this statement is true. And there's nothing I can say that makes it false because Hungary is from Europe. Let's look at the next statement. So we did first one. Now let's go on to the second one. If a number is divisible by 3, then it is odd. Can I think of an example to make it false? There is. A simple one is just the number 12. Let's say 12. If I divide 12 divided by 3, 12 divides into 3 and I end up with a 4. Well, 4 is an even number. So I just said that I just went ahead and showed you a counterexample. 12 is my counterexample. Okay, I'm sure there's other numbers we could use, but we're just showing one. All you need is one to show that it's false. So this statement is false. Okay, let's go on to the third one. If a month has 28 days, then it is February. Well, if you look at your calendar, all months have more than 28 days. So this one is a true statement. Okay, there's no other month I can prove or show that has 28 days. Only February has 28 days. So therefore it's a true statement. Okay, we're moving on to something called relatable conditional statements. I'm going to try to keep this very simple. There are three other type of conditional statements called the inverse, converse, and contrapositive. Okay, those that I just highlighted right here. Those are relatable to the conditional statement. So think of the conditional statement as your original. What we're going to do is we're going to mix this original into different forms, and those are called the related conditional statements. Okay, so let's start first with the original. The original statement says if angle A measures 15 degrees, then angle A is acute. Okay, so that's my original statement. Okay, now we're going to do the inverse of that. The inverse is known as the switch. You're going to switch the hypothesis and conclusion. So I am going to move angle A, the angle A is acute to the front. So my conclusion now moves to the hypothesis. Okay, and my hypothesis, angle A measures 15 degrees, is now going to get moved to my conclusion. The next one is called the converse. The converse is called negate. Okay, negate means to use the word not. Okay, so what we're going to do is we're going to take our original statement. So I'm going to go ahead and I'm going to take the hypothesis, angle A measures 15 degrees. I'm going to move it over here. And what I'm going to do is I'm going to change it by putting the word not. Okay? So what I'm going to do is I'm going to go ahead and put the word not. So I got to change this statement into something that says the word not. So if angle A measures 15 degrees, now it's going to say if angle A does not measure 15 degrees. So I'm going to go ahead and say doesn't or does not. Now I'm going to do the same thing. I'm going to go ahead and take my conclusion from the original, bring it here, and I'm going to negate both the statements, including the conclusion. So I'm going to go ahead and I'm going to say angle A is not acute. The last one is called the contrapositive. The contrapositive is you do the combination of a switch and a negate. So you're going to switch the originals by switching the hypothesis and conclusion around, and you're going to negate them by putting the word no. Okay? So what I would do is you're going to switch them. So I'm going to go ahead and take this one, an angle A measures 15 degrees. Now I'm going to put it on the back, and I'm going to put the word doesn't. So angle A does not measure 15 degrees. And I'm going to take my angle A angle A is acute. I'm going to put it now in the front, and I'm going to change that to angle A is not acute. So now my statement reads, if angle A is, and I think I need the word here, is, I think I put this backwards, I should put is not acute, then angle A does not measure 15 degrees. So these are your 4 relatable conditional statements. For problem number 4, we're going to identify and determine the validity of statements. What are the converse, inverse, and contrapositive of the following conditional? What are the truth values of each? If the statement is false, give a counterexample. So for example, we have, if the figure is a square, then the figure is a quadrilateral. Now we're going to do the inverse and then determine if it's a true or false statement. Okay? Well, on the first one, before we even go to the inverse, on the first one, this is going to be true. If the figure is a square, then the figure is a quadrilateral. Quadrilateral is 4 sides, something that has 4 sides. So this is considered true. The inverse is to switch the hypothesis to the back and the conclusion to the front. So I'm going to go ahead and move the conclusion to the front, and I'm going to move the hypothesis to the back. Now we read the statement. If the figure is a quadrilateral, then the figure is a square. Okay, this statement is going to be a false. Why false? Because it's saying that if it is a quadrilateral, if it has 4 sides, then it will always be a square. Well, what about a rectangle? Converse. Converse means to negate. So we want to put the word no or not. So we're going to go ahead and move our original statement, move our hypothesis down to the bottom, and we need to change it by putting the word not. So we're going to say the figure is not a square. So we need to put the word not. We also need to do the same thing for the figure is a quadrilateral. We're going to need to move that one over here to the conclusion, but we need to put the word not. We need to negate it. We need to make it the opposite. The figure is not a quadrilateral. Now we read the statement and determine whether or not it's true or false. If the figure is not a square, then the figure is not a quadrilateral. Well, again, on this statement, this is going to be a false. Alright, the last one. We need to switch and negate them. Okay? So that means that we need to switch this statement and we need to place it as a conclusion. So that's going to go right here. We take our conclusion, negate it, so I'm just going to take the one that says the converse, and I'm going to put that one in the front. So I negate and switch, or switch and negate. So now it reads, if the figure is not a quadrilateral, then the figure is not a square. Okay, so it's saying if the figure does not contain 4 sides, it cannot be a square. If you read this statement, that statement is true. Alright, this is our last section of problem number 4. Go ahead and summarize your notes